Hi everyone. Welcome to the Science Info channel. Today we will discuss about the most accurate flat map of Earth ever created by astrophysicists. Before we get started, make sure to like and share this video, smash the subscribe button and click the notification bell. Earth is a sphere, so how can it be accurately portrayed on a 2D map? Simply flatten Earth into two pancakes, one depicting the Northern Hemisphere and the other the Southern, with the equator running around the edge, a new study finds. These two pancakes represent the most accurate flat map of Earth ever made, the study researchers said. Unlike other flat maps, the new circular map doesn't downsize or supersize the area of certain oceans or landmasses. For instance, many 2D maps depict Greenland as about the same size as Africa, when in fact Africa is 14 times larger. Plus, unlike some rectangular maps that are very large, this is a map you can hold in your hand. Study lead researcher J. Richard Gott, a professor of astrophysics at Princeton University, said in a statement. The map can be printed front and back on a single magazine page, ready for the reader to cut out. Creating accurate 2D maps has dogged cartographers for centuries. To help determine the various problems flat maps face, Gott and study co-researcher David Goldberg, a professor of physics at Drexel University in Philadelphia, created a system to rate existing flat maps and published their results in 2007 in the journal Cartographica. Their system scored 2D maps on 6 types of distortions: local shapes, areas, distances, flexion, bending, or curvature distortions, skewness, lopsidedness, and boundary cuts, continuity gaps, like splitting up the Pacific Ocean. Maps that received lower scores were more accurate, they said. Well-designed globes, which are spherical like the Earth, would earn scores of 0. Lead researcher J. Richard Gott said one can't make everything perfect on a flat Earth map. A map that is good at one thing may not be good at depicting other things. Take, for example, the world map most people are familiar with, the Mercator projection, a staple found in many classrooms and the basis for Google Maps. While the Mercator projection is good at representing local shapes, it distorts surface areas near the North and South poles, so these regions are often chopped off, the researchers said. According to the team's rating system, the top-rated flat map projection is the Winkel Tripel, a map that originated in 1921, when German cartographer Oswald Winkel proposed it, and which the National Geographic Society now uses. This map drew a low score of 4.563, but it still had a boundary cut problem, because it split the Pacific Ocean in two, with one part on the right and the other on the left side of the map. This split creates the illusion that Asia and Hawaii are farther apart than they really are. To get around this boundary splitting problem, the researchers approached map making from a new perspective, with the hopes of designing a flat map with the least error possible, Gott said. We're proposing a radically different kind of map, and we beat Winkel Tripel on each and every one of the 6 errors. The end result, the pancake map, borrowed ideas from previous research on polyhedra, or many-sided 3D shapes. In 1943, the American architect Richard Buckminster Fuller drew outlines of regular shapes that made up a world map, and he wrote instructions for how his map could be folded into a polyhedral globe. But while Fuller did a good job detailing the continents, he wasn't as exact with the oceans, which introduced errors. For instance, Australia and Antarctica were too far apart on his creation. In a 2019 study posted to the R14 database, which has yet to be peer-reviewed, Gott considered envelope polyhedra, which involved gluing together regular shapes, back to back. This led to the idea of a double-sided circular map, he said. The new map, published February 15 to the R14 database, consists of 2 pancake maps that can be viewed side by side or back to back. Either way, the map doesn't have any boundary cuts. If you want to measure distances from one hemisphere to the other, just use a string or a measuring tape to reach around the side of one pancake to the other, Gott said. If you're an ant, you can crawl from one side to the other, Gott said. We have continuity over the equator. Africa and South America are draped over the edge, like a sheet over a clothesline, but they're continuous. The pancake map also has smaller distance errors than any other 2D flat map. For instance, its configuration means distances can't be more or less than 22.2% of what they are in reality, Gott said. In comparison, the Mercator and Winkel Tripel projections have remarkably high distance errors near the poles and at the left and right edges of the map. What's more, areas at the pancake map's equatorial edge are only 1.57 times larger than areas at the center, the researchers said. Gott said he's not aware of any other double-sided pancake Earth. Our map is actually more like the globe than other flat maps, Gott said. To see all of the globes, you have to rotate it. To see all of our new maps, you simply have to flip it over. Gott and his colleagues have also created pancake-like maps of Mars, Jupiter, the Sun, and other heavenly bodies. Thanks for watching.